So welcome to the video solution of day 15 Monday questions on signals and system. So I have kept 5 questions on continuous time Fourier series. So this will be the last question series on continuous time Fourier series, and we'll be moving on to the next topic of signals and system on the next Monday. So we have 3 videos of signals and systems: day 1, day 7, day 8, and day 15. Okay. So if you have gone through all the 3 videos, then your continuous time Fourier series topic is completely revised. And just before the gate exam, you can revise these 3 videos, and your continuous time Fourier series will be more than strong required for the gate exam. Okay, this much is more than sufficient for the gate exam, because these are the questions that are from the reference books, and they are the best questions available from any of the reference books. Okay, so I have followed Tarun Kumar Rawat for these questions, and Openham also for these questions. Chom series also for these questions. So the best questions I have collected and provided to you in these question series. Okay, so if you have done 3 videos, then continuous time Fourier series is done. Okay, now let's move on to the first question of this series. So this is the question where I have kept this question, where I want to tell you that if your signal xt is written is in cos and sine, then how to find out the Fourier series coefficients xn. Okay, so this is the exponential Fourier series coefficient of the signal. Okay, so this is the question that I've kept, that whenever a signal xt, a time domain signal xt, is written in terms of cos and sine, then how to find out the Fourier series coefficients of the signal. Okay, so the first step, okay, here the let me make it very clear that we know the formula of xn is 1 upon time period, integration over time period, xt e to power minus j n omega naught. So this is the formula of n omega naught t dt. Okay, this is the formula of xn, but this formula you cannot apply here because it will be very difficult to get the answer. Okay, so that's why I have kept this question, that we know that whenever xt is drawn in a figure format, like it's a triangular wave, a rectangular wave, a triangular wave, or a square wave, any wave is given in the figure format, then you use this formula to find out the exponential Fourier series coefficients of the signal. But if the signal xt is written in sine or cos terms, in addition of sine and cos terms, then you cannot apply this formula. You have to follow this procedure that I'm going to tell you. The first step is to find the period of the signal. Okay, if the signal is non-periodic, if the signal xt is non-periodic, then you cannot find the continuous time Fourier series. Okay, simple. So first of all, you have to find out the period of the signal. So xt is given to us 2 plus cos of 2 pi by 3 t plus 4 sine of 5 pi by 3 t. Okay, so we know that this is a DC signal. It will not affect the time period of the signal. The time period of this is equals to 3. The time period of this is the time period is 6 by 5. Okay, so now as we know that how to find out the time period of this signal, any signal is, we will first of all find the ratio t1 upon t2. So the t1 upon t2 ratio will be 3 divided by 6 by 5. If you do not know how to find the time period, then you go to the YouTube channel of EDAMIGO. There you will find the solution of the previous year questions. Okay, there I have explained in an exhaustive manner how to find out the time period of the signal. Okay, so the ratio will be 15 by 6. It will be 5 by 2. So the denominator is 2. Okay, so denominator here is 2. So x is equals to 2, the denominator is equals to 2. So the time period t0 will be equals to x into t1, that is equals to 6. So 6 is the time period of the signal. Okay, now after finding the time period, as we know that any signal xt is written as summation xn. So t naught is 6, omega naught will be equals to 2 pi by 6, that is pi by 3. Okay, so any signal xt can be written as n equals to minus infinity to infinity xn e to power plus j omega naught, that is pi by 3 omega naught nt. Okay, now since any signal xt is written like this, so since xt is given to us 2 plus cos of 2 pi by 3 t plus sine of 4 sine of 5 pi by 3 t. Now the step 2 is in the expression of xt, write cos theta as e to power j theta plus e to power minus j theta divided by 2, sin theta as e to power j theta minus e to power minus j theta divided by 2j. Now when you will write cos and sine as the exponentials like this, then your xt will have only complex exponential terms. Okay, so let us write it. So xt can be written as 2 plus e to power j 2 pi by 3t e to power minus j 2 pi by 3t divided by 2 plus 4 e to power j 5 pi by 3t minus e to power minus j, I have to move this, minus j 5 pi by 3t divided by 2j. So now xt has only complex exponential on the right hand side. Now as we know that xt is equal to summation xn e to power j omega naught nt, where omega naught is pi by 3, n equals to minus infinity to infinity. So we can say that xt is equals to dash 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 x of minus 1 e to power minus j pi by 3t plus x0 x1 e to power j pi by 3t plus x2 e to power j 2 pi by 3t and so on. Okay, now if we compare this whole expression with this expression, then we will get the values of xn easily. Okay, so first of all, if we compare this two, then we can see that only one term in this expression will be without e to power term. Okay, that is x0. So we will compare 2 with x0. So we can say that by comparing, we will get x0 is equals to 2. Okay, now we can see that since there is no term in this xt which has e to power j pi by 3 t minus pi by 3 t, so we can say that x of minus 1 is equals to 0. Similarly, there is no term of e to power j pi by 3t, so x1 is equals to 0. So we will compare these terms. So I can say that, and we can see that we will compare each term in this expression of xt in this expression of xt with, we will compare with xn e to power j n omega naught t. Okay, by comparing we will get value of xn and value of n. Okay, so let me write it. So step 3 is, after writing xt in terms of complex exponential, we will compare each term of xt with xn e to power j n omega naught t. Why we are doing that? Because xt is written as sum of xn e to power j omega naught nt. Okay, so let me write it. So it is 2 plus e to power j pi by 3 t divided by 2 e to power, sorry 2 pi by 3, it's 2 pi by 2 pi by 3 t e to power minus j 2 pi by 3 t divided by 2 plus 2 upon j e to power j 5 pi by 3 t minus 2 upon j e to power minus j 5 pi by 3. Now we'll compare each term with xn e to power j n pi by 3 t. Now when we compare with this, we can see that since there is no term of exponential here, so it will be e to power j 0. So we can say that n is equals to 0 and here x0 will be equals to 2. By comparing with this, we can see that here n will be equals to 2. Okay, and we can say that x2 will be equals to 1 upon 2. Here we can see that n is equals to minus 2 and x of minus 2 is equals to 2. Okay, we can easily see that now. Here also we can see that n is equals to 5 and x5 is equals to 2 upon j. Here we can see that n is equals to minus 5, x of minus 5 is equals to minus 2 upon j, minus 2 upon j. So this is the result. So we can say that x0 is equals to 2, x2 equals to x of minus 2 is equals to 1 upon 2, x of 5 is equals to 2 upon j, x of minus 5 is equals to minus 2 upon j. So this is the value of xn, and for other values of n, for other values of n, xn is 0. Okay, so this is the method. So this is a different kind of question, so that's why I have put it in the first number. So in this question I have explained you how to find out the Fourier transform of the continuous time Fourier series of a signal which is expressed as a sum of cos and sine terms. Okay, so this is the method and this is the answer. Now let's move on to the next question. So in this question, all the properties that you have read about the continuous time Fourier series will be revised. Okay, it's a very good question. Okay, so first of all, let us collect all the information given to us in the question. So first of all, it is given that xt is real and xt is odd. Okay, so what all we can collect from here is, when xt is real, then we know sorry, then we know that xt is equals to x conjugate t, because since it is real, the signal will be equals to its conjugate. Now if xt has Fourier series coefficient, the exponential Fourier series coefficients as ck, then we know that x conjugate t has Fourier series coefficient c conjugate minus k. Now when xt is real, then we know that xt is equals to x conjugate t, so ck will be equals to c conjugate minus k. Okay, done. Another thing, when xt is odd, then xt is equals to minus times of x of minus k. Now if xt has the exponential Fourier series coefficient ck, then x of minus t has exponential Fourier series coefficient c of minus k. Now when xt is odd, that is xt is equals to minus times of x of minus t, so we can say that ck is equals to minus times of c of minus k. Is it clear? So by comparing these two, we can see that, or first of all let me write it. So we can, from here we can see that conjugate both sides, c of minus k equals to ck conjugate. Okay, here we can say that c of minus k equals to minus ck. Now from these two equations we can say that c of minus k equals to ck conjugate, c of minus k equals to minus ck. So we can say that ck conjugate is equals to minus ck. That is, if we conjugate the variable, then it is becomes minus times of itself. Okay, if we are conjugating any variable, then it becomes minus times of itself. This implies that ck is imaginary. Okay, because then only if we conjugate a term, then it will become minus times of itself. It means that that term is imaginary. Okay, so this is the conclusion from the first given information, that xt is real and xt is odd. So we can say that ck is imaginary, and from here we can see that ck is odd also. Okay, so we can say that ck, that is the Fourier series, exponential Fourier series coefficient, is imaginary and odd. Done. So now let's see what is the second information given to us. Xt is periodic with period 2 and has exponential Fourier series coefficient xn. So I have used ck, so let us change it here. So if xt has exponential Fourier series coefficient xn, then xn is imaginary and xn is odd. Okay. Second, since time period is equals to 2, so omega naught is equals to 2 pi by time period, that is equals to pi. Third, it is given that xn is equals to 0 for n greater than, xn is equals to 0 for mod of n greater than 1. That is, the exponential Fourier series coefficients are non-zero for n equals to 0, 1 and minus 1 only. Is it okay? Now very important point is that since we know that xt is odd signal, okay, given to us in first information, first point in the question, since xt is odd signal, thus x0, that is the 0th exponential Fourier series coefficient, is 1 upon time period integration over time period xt dt. Okay, that is the average value of the signal over a period. Since xt is an odd signal, so it will have a 0 dc value, so x0 will be equals to 0. Okay, so finally we get that xn is non-zero only at minus 1 and 1. Okay, now the fourth point. Fourth point is 1 upon 2 integration 0 to 2 mod of xt whole square dt is equals to 1. Now what is this theorem? This says that this is actually the power of the periodic signal. Okay, power of the periodic signal. Now power of the periodic signal, we know that Parseval's theorem states that power of the signal, power of the periodic signal is equals to summation n equals to minus infinity to infinity mod of xn whole square. Okay, so this is the Parseval's theorem. I hope you all know this. So if xn is the exponential Fourier series coefficients, then mod of xn whole square summation minus infinity to infinity is the power of the signal. Okay, so from here we can see that summation n equals to minus infinity to infinity mod of xn whole square is equals to 1. Okay, now since as we know that xn is non-zero only at n equals to 1 and minus 1. Okay, so we can say that mod of x1 whole square plus mod of x minus 1 whole square is equals to 1. Is it okay? Now also we know that xn is odd, okay, and it is imaginary also. So we can say that x of 1 is equals to minus times of x of minus 1. Is it clear? So when x of 1 is equals to minus times of x of minus 1, or we can say that x of minus 1 equals to minus times of x1 is the same thing. So putting this equation in this equation number 1, let us say this is equation number 1, putting this in equation number 1, we can say that mod of x1 whole square, x of minus 1 can be greater than minus times of x of 1, so mod square will be x1 whole square only is equals to 1. So we can say that mod of x1 whole square is equals to 1 upon 2. I have to add pages here. Okay, so we can say that x1 is equals to under root of 1 upon j 1 upon 2 or j times of under root of 1 upon 2. Okay, because in both the cases mod of these values whole square will be equals to 1 upon 2 only. Okay, now since x n is imaginary, we cannot take this is wrong, we will have to take xn as imaginary. Okay, so there are two possibilities, it can be plus minus and it can be plus minus here also. Okay, so we cannot take these values, we have to take these values of x1. So there are two cases. Case 1, that x1 is equals to plus 1 upon root 2 j, and case 2 is x1 equals to minus 1 upon root 2 j. Okay, now when x1 is equals to this, then x of minus 1 will be minus times of x1, that is 1 upon root 2 j, and x minus 1 will be equals to here 1 upon root 2 j. Now as we know that xt is equals to summation xn e to power minus plus j omega naught nt n equals to minus infinity to infinity. Now since here n is equals to minus 1 and plus 1 only, so it can be written as n omega naught is equals to 2 pi by time period, that is pi. So it is equals to x1, that is 1 upon root 2 j e to power j omega naught is pi into 1 into t minus, because x of minus 1 is negative, minus 1 upon root 2 j e to power minus j pi into 1 into t. Okay, so here we have to put minus 1, so I have put minus sign here. So this is your xt. Okay, so this is your xt. Now if you solve it a little bit, you will get that if I take 1 upon root 2 j as common, I will get e to power j pi t minus e to power minus j pi t. I multiply divide by 2j, I will get multiply divide by 2j, I will get 2j into j divided by root 2, and this will become a sine pi t tau. So this will become minus root 2 sine pi t. Okay, now case 2, here xt will be equals to again summation xn e to power j omega naught, that is pi nt n equals to minus infinity to infinity. Now we can easily see that this will be equals to minus 1 upon root 2 j e to power plus j pi t plus 1 upon root 2 j e to power minus j pi t. Okay, now we can see that here this signal will be equals to plus root 2 sine pi t, because there is only a change of sign here. Okay, in between these two equations, in between this equation and this equation, there is only a change of sign. So if this leads to minus root 2 sine pi t, this will lead to root 2 sine pi t. So there are the two signals available as the answer. Okay, plus minus root 2 sine pi t is the answer. Okay, now let's solve the third problem. This will also help you in revising all the properties of the continuous time Fourier series. Now xt is a periodic signal whose exponential Fourier series coefficients xn is this given to us. So xn is given to us 2 j 1 upon 2 to power mod n equals to 0 and n is otherwise. Now the first part of the question is, they are asking that is the signal xt real or not? Okay, now as we know that when a signal is real, then xt is equals to x conjugate t. Now since it is given that xt has the Fourier series coefficients of xn, x conjugate t will have Fourier series coefficient of x conjugate minus n. Now when xt is real, we need that xn should be equals to x minus n conjugate. Clear? So we need that xn is equals to x minus n conjugate. Okay, now let us see, is this case valid here? Is this condition valid here? Now as we know that xn is equal to j times 1 upon 2 to power mod n. So x of minus n will be equals to j 1 upon 2 mod of minus n, that is equals to j times 1 upon 2 mod of n. Now x of minus n is equals to this. X of minus n conjugate will be equals to minus j 1 upon 2 mod of n. So we can say that xn is not equals to x of minus n conjugate. Thus this signal is not real. Okay, so xt is not real. Okay, now let us see the second part of the question. The second part of the question is xt even? Is the signal xt even? So let us see. Now as we know that when signal xt is even, that is xt is equals to x of minus t. Now if xt has the exponential Fourier series coefficient of xn, then x of minus t has the exponential Fourier series x of minus n. Now if xt is even, that is xt is equals to x of minus t, then we need xn is equals to x of minus n. That is xn or the exponential Fourier series coefficient should also be even. Now as we know that xn is equals to 2 n equals to 0 j 1 upon 2 to power mod n and otherwise. Now here this is xn. Now if we put x of minus n, then it will be equals to 2 n equals to 0 j 1 upon 2 mod of minus n is equals to mod of n and n is otherwise. Okay, so we can see that xn and x of minus n both are same, or xn is even. so xt is also even. Since xn is even, so xt is also even. Okay, so this is the solution to the second part of the question. Now the third part, d by dt of xt is even. So this is the question mark. Now as we know that it is a very simple problem, that if xt is even, then its differentiation d by dt of xt will be odd. Okay, if even signal is differentiated, then it will lead to an odd signal. If a signal is odd, then its differentiation will be even. So that's a property. Okay, now since xt was an even signal, as we have seen, xt is even signal, so its differentiation will not be even, it will be odd. So this is wrong statement. Okay, so d by dt of xt will be an odd signal. Okay, so this is the solution to this problem. Okay, now let's move on to the fourth problem. Okay, so this problem will also help you to understand all the, or to recall all the properties of the continuous time Fourier series. Okay, so let's solve the question. Okay, so it is given that xt has the Fourier series coefficient, that is xn. We have to find first of all the Fourier series coefficient of xt minus t naught, x of t plus t naught. Okay, so here we will recall the time shifting property. Okay, the time shifting property that states that if xt has the exponential Fourier series coefficient xn, then x of t minus t naught will have the Fourier series coefficient. Now in time shifting, the effect goes with the same sign, so it will be e to power minus j omega naught t naught n. Okay, similarly x of t plus t naught, the effect goes with the same sign, xn e to power plus j omega naught t naught n. So we can say that, and also the time period of this signal x of t minus t naught plus x of t plus t naught will be same as the time period of the signal xt. Okay, so x of t minus t naught, x of t plus t naught will have the Fourier series coefficient xn e to power j omega naught t naught n minus sign e to power j omega naught t naught. That will come out to be 2 times cos of omega naught t naught n into xn. Okay, so this will help you to recall the time shifting property. I have told you what is the time shifting property here. Okay, now let's solve the second part of the question. Second part of the question is, what is the exponential Fourier series coefficients of even part of xt? Okay, even part of xt. Now as we know that xt has even part, or I can say even part of xt is equals to xt plus x of minus t divided by 2. Okay, now as we know that if xt has the exponential Fourier series coefficients of xn, then x of minus t will have exponential Fourier series coefficient of x of minus n. So easily we can say that even part of xt will have the Fourier series coefficient x of n plus x of minus n divided by 2. Okay, now let's look at the third part of the third part, the exponential Fourier series coefficients of real part of xt. Okay, now if xt is any signal, then real part of any signal xt is equals to xt, that is the signal, plus its conjugate, because when we will do conjugate, then the conjugate will be equals to real part minus times of imaginary part, and signal is equals to real part plus imaginary part. Conjugate is equals to real part minus imaginary part. So when we add these two, then imaginary part is cancelled out and we will get 2 times the real part, so we will divide it by 2. Okay, to get the real part of xt. Okay, so for example, if you are not able to understand, so let us say that xt is equals to a plus jb, then its conjugate will be equals to a minus jb. Then since a is a real part, to get the real part out, we will divide this by 2. Okay, so this is the real, if you want to find real part of any signal, we just add with the conjugate and divide by 2. Now if xt has the Fourier series coefficient of xn, then x conjugate t will have the Fourier series coefficient x conjugate minus n. Okay, so xt plus x conjugate t divided by 2 will have the Fourier series coefficient xn plus x of minus n conjugate divided by 2. Okay, now let's move to the next part. Okay, so uh, let me explain you the properties, okay, that I'm using. Okay, so let me explain you the properties or proof of the properties. So let us see the time shifting property. Time shifting property of the continuous time Fourier series. So I'm just explaining you the properties. Okay, so if xt has time period t naught and the Fourier series coefficients are xn. Okay, so we know that the formula is xn is equals to 1 upon time period integration over time period xt e to power minus j n omega naught t dt. Okay, so this is the formula. Now let us say that we have a new signal, that is yt, that is equals to x of t minus t naught. Okay, now let's not use t naught here. Let us use some tau. Okay, so let us t minus tau. So I have shifted signal xt by tau. Now since shifting does not change the time period, the time period of this xt minus tau will remain same, that is t naught. And let us say that the Fourier series coefficients are yn. Yt has the Fourier series coefficients of yn. Since yt has the same time period of t naught, because time period does not change by shifting. So the formula of the Fourier series coefficient yn is 1 upon time period integration over time period yt e to power minus j n omega naught t dt. Now let us replace yt here. 1 upon time period integration over time period x of t minus tau e to power minus j n omega naught t dt. Now let us say that here the time period is minus t naught by 2 to t naught by 2. I am integrating. Let us say t minus tau is equals to alpha. Okay, so dt equals to d alpha. Here it will be equals to 1 upon t naught. This will change to minus t naught by 2 minus tau to t naught by 2 minus tau x alpha e to power minus j n omega naught alpha plus tau d alpha. So we can say that yn is equals to 1 upon time period. Now since this limit is again integration over time period only. Okay, this difference between the limits is also time period. So we can say integration over time period x alpha e to power minus j n omega naught alpha, okay, d alpha whole multiplied by e to power minus j n omega naught tau. Now why this term is outside? Because the integration is on alpha and this term is not having the variable alpha, so that's why I kept it out. Now we can see that this is actually equals to xn. Only the variable here is alpha, and in the equation of xn here the variable was t. Okay, so we can say that yn is equals to xn e to power minus j n omega naught tau, or we can say that x of t minus tau has the Fourier series coefficient. The effect goes with the same sign. Okay, so this is the time shifting property. So I proved this property because generally students used to skip these proof. They used to learn that this is the result, but sometimes gate used to ask the questions from within the proof also. So you have to prepare, you have to be like, you should know how to prove the properties. Okay, it is very important for the gate exams. Now I have proved the time shifting property. Now the second property that I have used is time reversal. Time reversal. Okay, time reversal is if xt has the Fourier series coefficient xn, then x of minus t has, let yt is equals to x of minus t has Fourier series coefficient yn. So we have to find out the relationship between yn and xn. So we can say that xn is equals to 1 upon time period integration over time period. Okay, now xt has some time period, that is t naught. So x of minus t will also have the same time period. So we can say that yt will have time period t naught same as that of xt. Okay, same as that of xt. So we can say that yt has the Fourier series, the formula of yn will be equals to 1 upon time period integration over time period yt e to power minus j n omega naught t dt. So let us say we are integrating from t naught by 2 to t naught by 2 x of minus t e to power minus j n omega naught t dt. So let us say minus t is equals to alpha. So dt is equals to minus d alpha. So this yn will be equals to 1 upon time period integration t naught by 2 to minus t naught by 2 x alpha e to power plus j n omega naught alpha minus d alpha. Okay, so we'll put a minus sign here, d alpha. Now this minus sign is used to change the limits. interchange the limits. Okay, now this is your yn. Now as we know that xn was equals to 1 upon time period integration over time period xt e to power minus j n omega naught t dt. Now we can see that these two equations, this equation RHS and this equation RHS, both are exactly similar. The only difference here is here we have a minus sign and here we do not have any minus sign. Okay, in the here we do not have a minus sign. So we can say that if we replace if we replace n by minus n in this equation, then we will get, so x of minus n will be equals to, we are replacing n by minus n in this equation. Okay, now the RHS of this equation number, let us say 2, is equals to the RHS of this equation number 1. So we can say that yn is equals to x of minus n. So we can say that if xt has the Fourier series coefficient of xn, then x of minus t has the Fourier series coefficient x of minus n. Okay, now let me prove one more property, third property, that is conjugation in time domain. That is, if xt has the exponential Fourier series coefficient xn, then x conjugate t will have exponential Fourier series coefficients question mark. So let us say yt is equals to x conjugate t and the exponential Fourier series coefficients are yn. Okay, so we know the formula, that is xn is equals to 1 upon time period integration over time period xt e to power minus j n omega naught t dt. Okay, so this is the formula of xn. Now since yt is equals to x conjugate t, so yt will have the same time period as that of xt because conjugation does not change the time period. So we can say that yn is equals to 1 upon time period integration over time period yt e to power minus j n omega naught t dt. This is equation number 1, this is equation number 2. Now we will replace yt by x conjugate t. So we will get 1 upon time period integration over time period x conjugate t. Okay, now let us conjugate both sides in equation number 1. Okay, so in equation number 1 we are conjugating both sides, so we will get this. Equation number 3. Okay, so by conjugating both sides on equation number 1, we will get equation number 3. Okay, so if we conjugate here, we will get a plus sign in the power. If we conjugate here, we will get a conjugate sign on xt. Now this is equation number 4. Okay, now in equation number 3 we replace n by minus n. So we get x of minus n conjugate is equals to 1 upon time period integration over time period x conjugate t. So we are replacing n by minus n here. So n omega naught t dt. This is equation number 5. Now if we compare equation number 5 and equation number 4, we get that their RHS are same. So we can say that yn is equals to x minus n conjugate. Or we can say that x of conjugate t has the exponential Fourier series x of minus n conjugate. So these were the properties that I have used in these questions. One more property that I am going to use, it is very important property. Okay, it is very important property. Okay, so let's look at it. time scaling. Okay, time scale. Now let us say that xt has the exponential Fourier series coefficient xn, where xn is equals to 1 upon time period integration over time period xt e to power minus j n omega naught t dt. This is very important property and the proof is very important. Okay, just look at it. So let us say yt is equals to x of at. Okay, where let us say that a is positive, and just for the sake of simplicity, let us say x is equals to yt equals to x of 3t. Okay, now x of 3t means we are compressing the signal. Okay, from xt to x of 3t we are compressing the signal. Okay, so if xt has time period t naught, yt will be periodic, obviously will be periodic with period t naught by 3. Okay, so if xt has omega naught as the fundamental frequency, yt will have 3 omega naught as the fundamental frequency. It is very important. These points are very important. Now let us say yn are the exponential Fourier series coefficients of yt. Okay, so yn will be equals to 1 upon time period. So here time period is t naught by 3. Integration over time period. So let us say minus t naught by 6 to t naught by 6 x of 3t e to power minus j n. Here omega naught is 3 omega naught t dt. Okay, now let us say 3t is equals to alpha, dt is equals to d alpha by 3. So yn is equals to 3 by t naught integration minus t naught by 2 to t naught by 2 x of alpha. Here we have, okay, 3t, so e to power minus j n omega naught alpha d alpha by 3. So these two will cancel out. This is equals to 1 upon time period minus t naught by 2 to t naught by 2 x of alpha e to power minus j n omega naught alpha d alpha y n. Okay, now we can see that this formula is exactly equal to the formula of xn. Okay, so we can say that yn is equals to xn, that is the exponential Fourier series coefficients of x3t is equals to the exponential Fourier series coefficients of xt. Okay, the Fourier series coefficient values will be exactly similar. The only difference is in case of xt, the plot of exponential Fourier series coefficients, that is xn, that is x0 will be at 0 frequency, x1 will be at omega naught frequency, x2 will be at 2 omega naught frequency, x3 at 3 omega naught frequency, and so on. Similarly on the back side, minus omega naught, minus 2 omega naught, and so on. Okay, so this is the case of xt. If we draw the exponential Fourier series coefficients of xt on the plot of omega, then we'll get this. I have to add pages here. Okay, but if we draw the plot of the exponential Fourier series coefficients of x3t, now here the fundamental frequency, that is omega naught dash, is equals to 3 omega naught. Okay, and the values of exponential Fourier series coefficients yn is equals to xn, that is At 0 frequency we will get y0 that is equals to x0. Okay, at omega naught dash frequency, that is the fundamental frequency, that is actually equal to 3 omega naught, we will get y1 that is equal to x1. Then at 2 omega naught dash, that is 6 omega naught, we will get y2 that is equals to x2, and so on. Okay, so are you getting the difference in the, so we can say that the exponential Fourier series coefficients are exactly similar. The only difference here is in the plot. Okay, in the plot there is a difference. Here we will have minus 1, y minus 1 at minus omega naught dash, that is equals to minus 3 omega naught is equals to x of minus 1. Okay, the plot is different, the values are exactly similar. Okay, why the plot is different? Because the fundamental frequency is different in case of x3t. Okay, now this is very important. Okay, now there is one part in this question, you can see that the last part. Okay, so I am doing it first. So the last part is, if xt has the exponential Fourier series coefficients of xn, x of 3t minus 1 will have the exponential Fourier series coefficient, that is question mark. Okay, so here two properties are there, that is time scaling property and time shifting property. Okay, time scaling and time shifting both are there. Now first of all, let us start with xt. So xt has the Fourier series coefficients, that is xn, and the fundamental frequency is omega naught. Okay, now let us do time scaling first. So we have x of 3t. Okay, so xn. Now when we do x of 3t, so the fundamental frequency is omega naught dash, that is changed, and that is equals to 3 omega naught. Okay, now this signal x of 3t has the fundamental frequency omega naught dash. So let us say that x of 3t is equals to yt. Okay, so let us say that x of 3t is equals to yt. So yt has the Fourier series coefficients x of n, and the fundamental frequency is omega naught dash. Okay, now we do the time shifting. Yt minus 1 by 3 will have the Fourier series coefficients x of n, of it goes with the same sign, e to power minus j 1 by 3 into omega naught dash into n. Okay, so this is the property we have seen. Yt minus tau will have the Fourier series coefficient equals to xn e to power minus j tau into omega naught dash into n. Okay, now we can see that this is equal to xn e to power minus j omega naught dash equals to 3 omega naught n will be the Fourier series coefficient of yt minus 1 by 3. Now why I have shifted by 1 by 3? Because xt is equal, yt is equals to x of 3t. So yt minus 1 by 3 will be equals to x of, so yt is equals to x of 3t. So if we change t, we have to change t here also. So we can say that yt minus 1 by 3 is equals to x of 3t minus 1 by 3 is equals to x of 3t minus 1 will have the Fourier series coefficient xn e to power minus j omega naught n. So this is a very important question that has shown you that how to move ahead with the signals in which shifting and time scaling both are done. Okay, there might be a signal where shifting, time scaling, and time inversion, all three are done together. Okay, so you have to be very careful in such questions. Okay, now let us move to another part of the question, another property that is being used. I think this will be the fourth property that I'm proving, because it has been used in one part of the question. That is, if xt has the Fourier series coefficient xn, then d by dt of xt, what is the Fourier series coefficient of this? Okay, now this is very simple problem. Now as we know that xt is written as summation xn e to power j omega naught nt dt minus infinity to infinity. Now first of all, let's analyze this expression. This expression says that on the LHS we have the time domain signal. In the RHS we have this term, which is the exponential Fourier series coefficient of signal xt, and then we have the exponential term, sorry there is no dt here, okay, then we have the exponential. Now sorry, I have to add few pages here, 2 pages will be sufficient. Okay, now this is the expression that you should know. Okay, this is the expression that you all know. But if you analyze the expression says that on the LHS we have the time domain signal which is periodic. On the RHS we have this term which is the exponential Fourier series coefficients and the exponential term. Now if we differentiate this term, both sides we will get d by dt of xt is equals to summation n equals to minus infinity to infinity j omega naught n xn e to power j omega naught n. So using the same funda, we will say that on the LHS we have the time domain signal. This is the time domain signal. On the RHS, this is the exponential Fourier series coefficient corresponding to this signal. Okay, and this is the exponential term. So we can say that d by dt of xt will have the exponential Fourier series coefficient, that is j omega naught n xn. If we double differentiate it, we will multiply it by 2 times. Simple. J omega naught n whole square xn minus omega naught square n square xn. So this was the one part of the question. Okay, so this was, if you go through the question, then you will see that this is actually the D part of the question, where d2 over dt2 xt exponential Fourier series coefficient is asked in the question. So this is the D part of the question that we have solved with the help of this property. So I have proved the property and I have solved the question both. Now let us come to the last question, that is the fifth question. Okay, so let us see all the properties that is given to us, all the content given in the question. So it is very important to analyze all the content. First of all, it is given that xt is real. So xt is real means xt is equals to x conjugate t. And if we say that the exponential Fourier series coefficient is xn, so xn equals to x conjugate minus n. So this is the derivation from the first point. Second point, xt is periodic with period 6. So time period is equals to 6, omega naught is equals to pi by 3. Third point, it is given that xn is equals to 0 for n equals to 0 and n greater than 2. Okay. Fourth point, it is given that xt is equals to minus times of x of t minus 3. Now what is this property? If you recall, in the previous video of the signal system, previous Monday, we have discussed that this is the property of the half wave symmetry, that is xt is equals to minus times of x of t plus minus t naught by 2, and we have proved that we have proved that in the case of half wave symmetric, the exponential Fourier series coefficient is 0 for even values of n and non-zero for odd values of n. Is it clear? So now one more thing that we can prove here is that since xn is equals to x of minus n conjugate. Okay, so we'll prove one more point here. Okay, so I'm shifting this down. Okay, now since it is given that xn is equals to 0 for n equals to 0 and n greater than 2, means here we can see that xn is non-zero for 1 and 2, n equals to 1 and 2, minus 1, minus 2, minus 3 and so on. It is non-zero for these values because here it is written n greater than 2, not mod n greater than 2. Okay, but from the first property we can see that since xn is equals to x of minus n conjugate, okay, so we can see that since xn is 0 for n equals to 3, 4, 5 and 6 and so on, so we can see that x3 is equals to x of minus 3 conjugate, or we can say that x of minus 3 equals to x of 3 conjugate. Now since x of 3 is equals to 0, so x of minus 3 will be 0, right? Similarly, x of minus 4 will be 0, x of minus 5 will be 0. So from here we can see that, from this first property and the third property that we know, so this implies that xn is non-zero for only n equals to 1 and 2, n equals to minus 1 and minus 2 only. Is it clear? Now from the fourth property, I'm shifting this property to the top. From the fourth property, since xn is 0 for n even and xn is non-zero for n odd, this implies that xn is non-zero for n equals to 1 and minus 1 only. And what will be the relationship between 1 and minus 1? x1 is equals to x of minus 1 conjugate because xn is real. Sorry, xt is real. Okay. So this is the fourth property that we have proved. Now let us move to the fifth property. It is given that 1 upon 6 integration minus 3 to 3 mod of xt whole square dt is equals to 1 upon 2. Okay. So what is this property? This is given that power of xt is equals to 1 upon 2. Now using the Parsifal's theorem, the Parsifal's theorem states that summation n equals to minus infinity to infinity mod of xn whole square is equals to the power of the signal, that is half. Since xn is non-zero only for 1 and minus 1, we can say that x1 mod square plus x minus 1 mod square is equals to half. Okay. Now the sixth point in the question, it is given that x1 is positive and real number. x1 is positive and real number. Okay. So we can see that x of minus 1 is equals to x1 conjugate. So their magnitude square will be same. So we can say that x1 whole square plus x1 mod square is equals to 1 upon 2. x1 mod square is equals to 1 upon 4. So x1 is equals to 1 upon 2 plus minus, or we can have x1 is equals to plus minus j 1 upon 2. Okay. Now since it in the question it is given that x1 is positive and real number, so only one possibility is there, that x1 is equals to 1 upon 2 and x1 conjugate, sorry, x of minus 1 is equals to x1 conjugate. So x of minus 1 is equals to 1 upon 2, because 1 upon 2 conjugate is also 1 upon 2 only. Now we can easily write xt is equals to summation minus infinity to infinity e to power plus j. Here omega naught is pi by 3 n t. Now since xn is 0 non-zero only for 1 and minus 1, so this is equals to 1 upon 2 for n equals to 1 upon 2 e to power j pi by 3t plus n for n equals to minus 1, 1 upon 2 e to power minus j pi by 3 t. So this will come out to be cos of pi by 3 t is the signal xt. Okay, so this is the answer to the question. So using these 5 questions, I have tried to give you the whole overview of the continuous time Fourier series. We have tried to learn all the important properties of the continuous time Fourier series. So thank you students, give us your feedback and keep sharing these lectures. Thank you.